The next one is the weighted least connections. So the weighted least connections is least connection factor is there, but there is another factor which is connection limit. Connection limit is parameter that we can configure on the pool member or the node. The connection limit means the total number of connections that this server can handle. So if you have server 1, 2, and 3, you talk to the application server admin and tell him your application on server 1, how many connections can handle. Maybe he will tell us that server 1 can handle 1000 connections, server 2 can handle 2000 connections, server 3 can handle 3000 connections. This is as per the application team feedback. So we set the connection limit. As you see, we go to pool, we click on the member. This is member 1. We set the connection limit parameter to be matching what we have been told by the application admin. Now, at any point in time, if we look at the connections, let's say that currently there are 300 connections on each server. Now, 300 out of 1000, it's almost 30%. Now, 300 out of 2000, it's 15%. 300 out of 3000 is like 10% only. So we see that server 3 is underutilized. So all connections should go to server 3. Once we bring server 3 to the 15%, then we start round robin between server 2 and server 3. So the aim of the big IB is to keep this percent the same, the percentage. The aim of the big IB is to keep this percentage equal. So this server can handle 1000, so 50% is 500. 50% of server 2 is 1000. 50% of server 3 is 1500. So we try to keep the percentage equal. Let's actually do that. Test this weighted least connection in the lab and see. So to test this, let's go to the pool. We have the pool with 3 members. Let's go to member 1. The connection limit currently is 0, means no limit. Let's say for member 1 we put 2 connections maximum. Server 1 can handle. Server 2 can handle maximum of 4 connections. Server 3 can handle maximum of 6 connections for the sake of testing. So 2, 4, 6. Let's go to the client now and test. Let's use the Explorer 192 server 1. Let's use private to avoid cache and avoid using the same connection. So 192, we go to server 1. So 2 sessions to server 1. We should now be at the max. We shouldn't hit server 1 again. Let's see. No, we're hitting server 1. It could be cache, so let's continue. Server 2, now 2 connections to server 2. Now server 3. Now server 3. Again, server 2, back to server 2. You see, we're not going back to server 1 because server 1 is at its maximum, because we said server 1 can handle only 2. So 2 is already open. We will not go back to server 1 unless one of the connections time out. We will continue. Now we shouldn't be seeing server 2 anymore because I think we hit 4. Yeah, no more server 2 even. Now I think we hit the 3 maximum. Let's go back to statistics. There you go. 3 of them at their maximum number of connection. And what is the maximum? 2, 4, 6 maximum connections. So the weighted least connection is working as expected. It goes back to the connection limit. Now the connection rate limit, the second parameter, actually this will be concerned about the new connection per second. So when you have a server, the server can handle 1 million connection concurrently. So the number of concurrent connection is what we are referring here to the connection limit. Concurrent connection. So at the same time, this server can be talking to 1 million users, 1 million connection. But in terms of setting up new connections per second, the server maybe can handle 100,000 new connection per second only. If within the same second I get more than 100,000 connections, I cannot answer to all of them. I answer to 100,000 and the remaining I will drop. They have to come back in the next second because I have a limit when it comes to new connections per second. So if the application team requires us to set such a limit, we can do so as well per pool member or per node. So moving forward with the dynamic load balancing algorithm or methods, we have the observed load balancing method. It uses the dynamic ratio. In case you don't remember the dynamic ratio, you can go back. So the dynamic ratio, where the big IB will assign a ratio based on a feedback coming from SNMP data collection agent. So you install the data collection agent on the server. The data collection agent will send utilization information to the big IB about CPU, about memory, disk performance. So once the big IB receive the utilization information from the 3 servers that we have, it will say, for example, if server 1 utilization is 10% only, and server 2 and 3 utilization is 50%, so it will assign ratio, higher ratio to server 1 so that more requests will go to server 1. Now, the observed, it uses the dynamic ratio algorithm, same concept. We monitor the server and we assign the ratio based on the number of connections, number of layer 4 connections. So we don't have to install SNMP DCA on the server, no. Because the big IB is able to see all the connections going to the server, here the big IB will take snapshot every 1 second. Every 1 second, the big IB will calculate, okay, on server 1, how many L4 connections, on server 2, how many L4 connections, on server 3, how many L4 connections, and it will assign a ratio to each server accordingly. Let's just make it a bit clearer on a whiteboard. So if we say, this is our first second, on node 1, node 2, node 3, the big IB observed 200 connections, L4 connections on node 1. On node 2, 250. On node 3, 400 connections. At this point in time, the big IB says we need to assign higher ratio to node number 1 so that it receives more requests. Maybe it will say, for example, give this 4, give this 3, give this 2, for example. Um, it's not accurate 100%, but you can do the math so to figure out the ratio, but it's a dynamic ratio. The big IB will calculate what ratio to assign to each node based on the current L4 connections, and this will happen every second. So another second, which is the second, this is the first, we'll do the same calculation and assign new ratios based on the new number of connections that we observe on the nodes. So as you can see, because it's happening every second, it's not recommended for large pools because this will be a lot of work, a lot of overhead on the big IB to calculate every second, assign new ratio, etc., etc. Predictive, it's very similar to the observed, it's the same, but instead of doing it over 1 second, it will go over longer period of time. So it will take more time so that the big IB will observe the trend of utilization of node 1, the trend of utilization of node 2, the trend of utilization of node 3. It will see the trend and accordingly it will assign ratio to each node. Fastest, it observes or it monitors the outstanding L7 requests. What is that? Let me go back to the whiteboard. So we have the big IB. Behind the big IB, we have the 3 nodes. Node 1, node 2, node 3, serving our web application. So I have users here. When users send request to the big IB, it's considered layer 7 request. Why? Because we're asking for a web application. Then the big IB, and remember, this is full proxy architecture. So request from user to the virtual server. Then there will be another request from big IB, and let's say for node 1. Two separate connections. Now, with the fastest algorithm, the big IB will collect the statistics. Okay, currently, how many requests I have pending with node 1 to respond? Because when you initiate request to node 1, it will take few milliseconds for node 1 to respond. And the same, if I have thousands of users, so I expect that there are a lot of requests going to each node. So each node will be handling few thousands of requests. Now, with the fastest, the big IB will track how many layer 7 requests pending response from node 1, how many layer 7 requests pending response from node 2, and how many pending response from node 3. So if we say there is 100 here, there is 90 here, and there is like 120 here, so we seems to see that node 2 has less layer 7 requests pending for answer. So implicitly, we can conclude that node 2 is the fastest now to respond. If I have a new user now coming, I have to send it to node 2 because it will be the fastest node to respond. So it's L7 response tracking mechanism that Big IP will use, but again, it requires L7 and TCP profile to function. Least sessions, this is something related to persistence. We will revisit this once we talk about the persistence profile and the stickiness concept.